Okay, so today let's take a look at this LeetCode problem 701, insert into a binary search tree. So the problem says you are given the root node of a binary search tree and a value to insert into the tree. Return the root node of the binary search tree after the insertion. It is guaranteed that the new value does not exist in the original binary search tree. Notice that there may exist multiple valid ways for the insertion as long as the tree remains the binary search tree after insertion. You can return any of them. So we are given 3 examples here. And we are also given some constraints. Let's take a look. The number of the nodes in the tree will be in the range 0 to 10 to the 4th. And also, node dot value is between minus 10 to the 8th and 10 to the 8th. And all the node has unique values. Okay. And the to be inserted value is between minus 10 to the 8th and 10 to the 8th. And it's guaranteed that the value does not exist in the original binary search tree. So this already been mentioned in the problem statement, right? Okay, now let's take a look at the example. So in the first example, the binary search tree have 5 tree nodes. The root node is 4. And then we have node 2, as its left child node, and node 7 as the right child node. And for node 2, its left child node is 1 and right child node is 3. Okay, so this is the binary tree we are given. The value that we want to insert into this binary tree is 5. So how can we insert this node 5 into this binary search tree? As the problem statement says, there may have multiple valid ways to insert the value. What does this mean? So this should be a valid insertion. We insert 5 as the left child node of node 7. So this could be one valid insertion, right? And another one could be we insert this 5 as the new root. And then we move 7 to the right side. Node 7 becomes the right child node of node 5. So this tree is also a valid binary search tree. So at least here we have 2 different ways to insert value 5. Now how can we design and implement an algorithm that can insert any given value? So I think the idea is so we can use a pointer. Originally, the pointer points at the root. Every time we compare the root, the current root, with our to be inserted value. If to be inserted value is larger than the root node, then we go to the right subtree. Otherwise, we go to the left subtree. We repeat these operations until we reach a point that the pointer is null. So in this case, we first compare 4 and 5. 5 is greater than 4. We go to the right side. Then we compare 5 and 7. 5 is less than 7. We go to its left subtree. But now its left subtree is null. So we stop here, and then we add node 5 as the left child node, and 7 becomes the parent node, right? And what if the value we want to insert is 8? So similarly, we compare 8 with 4, it's greater than 4. Okay, we go to the right. 8 is also greater than 7, we go to the right. Now right is null, we insert it to the binary search tree as the right child node of node 7, right? And what if the value is 0, since all the values are unique? And let's say we have a value 0 now. Okay, we compare 0 with 4. 0 is less than 4, we go to the left side. 0 is less than 2, we go to the left side. 0 is less than 1, okay, we go to the left side. Okay. Now the left side is null, our pointer points at null. We add this 0 as the left child node to node 1, right? So this is going to be our idea to insert the value. And the corner case could be, what if our root node is null? In that case, the tree is just an empty tree, a blank tree. So we just need to create the node, right, for the given value, and then we return this node as the root. Okay, so after having the idea, I think let's try to code it. So the first thing we need to do is to check the corner case. If root is null, we just return new tree node. We are parsing the value. So in C# here, all the arguments in the constructor are optional, right? If you don't specify the value to these arguments, the constructor will use the default values. And this is a good feature of C#. In Java, we won't have this one. I think in Java, yes, there is another constructor which you can pass only the value. Okay, and now we just need to compare our to be inserted value with our root every time. So we need a pointer. So pointer tree node, let's call it current. Firstly, originally this pointer first points at the root. While current is not null, we compare our current value with our new value. So what if the current value is less than the new value we want to insert? There are two cases, right? One case is if the pointer, let me make it clear, still use 5 as example. There are two cases. The first case is after the move, the pointer is not null. In that case, we need to keep moving. Either go to the left side or go to the right side, right? That's the first case. Second case is if we go to a position that is null, we need to insert the new node. Okay, let's handle that. If current let me think about it. So in this case, current value is less than okay, in this case, the current node is less than the new value. We are supposed to go to the right side. Okay, so if current.right is not null, our current will go to the right side. Otherwise, we're gonna insert that node to the binary search tree and break the loop, right? And similarly, we handle the case that current.value is greater than the new value. Okay, then we just need to return the root. Let's run the code. Okay, let's submit it. Okay, accepted. And this is the iterative way. So can we do an implementation by using recursion? So recursion, we need to call the function by itself, right? So similarly, we also need to compare our to be inserted value with the root every time. And we then go to either left side or right side, depends on the comparison. If root value is less than our new value, then the root.right we first insert our new node to the right side. And suppose we have the new tree, we just need to return the node to root.right. Yes, okay, let's code it. Corner case is the same. So if root.value is smaller, is less than value, then root.right, we call this function. And now we update the root to be root.right. Else root.left. At each recursion level, we need to return the new root, right? Let's run the code. It's wrong. Oh, I have a typo here. Okay, so this recursive way also works. So basically the idea is we compare 5 with 4, and then we go to 7, right? And we compare 7 and 5, then we go to its left. And now our root is null. We create a new root 5, and we return, right? So last time when we call the insert into binary search tree, our root node is 7. Our root node is 7. And then root.left is our point to our new root. And later we return 7 to our root, which is 4. And then eventually we return 4. So this is how the recursive solution works for this example. Okay, that's it.